Good day, welcome to Gifted and Science and Technology Chemistry class. My name is NC Joshua. Today we'll be looking at hybridization. What is hybridization? Simple definition is the mixing of atomic orbitals to produce a hybrid orbital. Now it means that the atomic orbitals that we have, they are unhybridized. So in mixing them, we now have a hybrid. Now example of such atomic orbital that we can mix, we have x orbitat, we have the p orbitat, we have the d orbitat, and we have the f orbitat. Now remember that the x orbitat it has its shape, and the shape of the s orbitat is spherical in shape. We have the p orbitat, and the p orbitat is degeneratable or degenerated. It has 3 orbits. Then we have the shape here is called the dumbbell, while the d orbital is called the double dumbbell. But this has a multiple loop shape, so we say it is complex. It has a complex shape. Now all of these are unhybridized, but when they now mix with other orbitals, we now have what we call a hybrid. So we will be seeing some examples of hybrids, atomic hybrids. What are the examples of atomic hybrids? Now remember, X is it's not degenerated, but P, D, and F are degenerated. So we only have X. So X as an atomic orbit that is unhybridized can combine or can be mixed with one of P. Now remember, P has, you have your P like this. So P has 3 orbitals. So X mixing with 1P will give us a hybrid which is called sp hybridized. So and the sp hybridized is linear in shape. So compounds that are sp hybridized, they are linear in shape. So we have X combining with 2P, then it gives us sp2. X combining with 3P to give us sp3. Then P, we've exhausted P because P degenerates to this manner. But D has 5. 1, 2, 3, 4, 5. So just as P is exhausted, so we'll now go, there's nothing like sp4. No, we have maximum P as 3, so we have sp3. So now look at this, it becomes sp3 D1. So there's a 1 here, so sp3d. So now watch this. sp2 is trigonal planar, sp3 is tetrahedral. So compounds that are sp3 hybridized, they are tetrahedral in shape. Then we have trigonal bipyramidal, that's the sp3d. Then we have the octahedra, which is sp3d2. So there are others, sp3d3. All these are examples of hybrids. So now look at a short formula here to assist us in solving for hybridization. Now take note, in a compound, we have the centralized atom in a compound. That centralized atom is actually the atom that is undergoing hybridization. So our focus is on the centralized atom, then with other subordinates that are attached to the centralized atom. So look at this formula. H here means hybridization is equal to 1 over 2, open bracket. The V here is the number of valence electron of the centralized atom. For instance, I have H2O, water. O is the centralized atom, while I have HH. So H2O, water, is my centralized atom. Sorry, oxygen is my centralized atom. For instance, CH4. So it is CHHHH. So for this case, carbon is my centralized atom. So in solving hybridization, my V here is the valence electron of the centralized atom. What is valence electron? Electron in the outer shell of the centralized atom. That's my V. My N here is the number of monovalent atom attached to the centralized atom. Monovalent atom are atom with just one valency atom that have one electron in their outer shell. Those are monovalent atoms. So we now see that N here is strictly for monovalent atom. Now, when we go further, what is now the C? C is a number of cation, then A is a number of anion. So we'll be looking at examples of all of some compounds and their hybridization as we go forward. Now, considering the first three we just did, I could have a structure like this, and I will ask you, what is the hybridization of this structure? Now, I have CH3 as against CH, double bond CH, then single bond C, triple bond CH. Now, how can you answer this? Now, it's already important to know that alkane, which is ANE, are sp3 hybridized, then alkene, which is ENE, are sp2 hybridized, while alkyne are sp hybridized. Now, what about alkane? Single bond. What about alkane? Double bond. What about alkyne? Triple bond. So when you look at this structure, you see the three of these bonds present in them. So it means that when you see a triple bond is sp, a double bond is sp2, a single bond is sp3. So in this compound, what is the hybridization of this compound? It is sp, sp2, and sp3 hybridized. So such a structure has the whole of this hybridization in itself. So it is important to know that this is the hybridization of such a structure. Okay, let's see our first example. What is the hybridization of the following? Now, this is CH4 methane. This is C2H2 ethane, while this is ethyl. Now look at this. This is methane. This is ethane, while this is ethyl. Ethine, ethane, ethane, ethyl. This is the YNE. This is the ENE, and this is the ANE. Now, what is the formula for calculating? We said H is equals 1 over 2 open bracket V plus M minus C plus A. That's the formula to solve. Now let's go straight to the point. What's for number one? Hybridization is equal to 1 over 2 open bracket. We said V is the number of valence electron in the centralized atom. For this compound, it's expressed as C H, 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 H. That's carbon is a centralized atom. But this is expressed as C, double bond C, H, 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 H. Then what about this? This is written as C, triple bond C, H, then H. What do I want you to know here? I want you to know that the valence electron of the carbon in this is 4, but the valence electron of carbon in this order 2 is 2. Carbon has two valencies. It's either it is 4 or 2. So for this case, the valence is 4, but for this, please just take it as your 4 divided by 2 carbon atoms that are present. Then it becomes 2. So here, that's why you have carbon having a possibility of carbon 4 and carbon 2. So in this case, carbon is 2, but in this case, carbon is 4. So come back here. What is now the number of valence electron in carbon in this case? It becomes 4 plus M, we said, is a number of monovalent atom attached to the centralized atom. So this is the centralized atom. These are our monovalent atoms attached. How many monovalent atoms is attached? 1, 2, 3, 4. So I'll come back and say plus 4. Now this is the number minus C. C is the number of cation plus anion. Now if you check this compound, there is no cation, there is no anion. So it's as good as nothing to add here. Now what is now this? And I have H is equal 1 over 2 times 8, meaning hybridization equals to 4. When hybridization equals 4, what does that mean? It means that we added 4 orbitals to get our answer. So now come back to this place. How many orbitals are we adding? We are adding just 2 atomic orbitals, s and p. It gives us sp. Here we are adding 3. We now have sp2. But in this case, we are adding 4. 1, 2, 3, 4. So when hybridization equals 4, what is the hybrid that is formed? Is sp3. So if hybridization equals 4, my answer is sp3, meaning this compound is tetrahedral in shape. Now let's look at another example, which is example B. Example B, remember I've told you that for this case, the carbon atom here, the valence electron is 2 and not 4. So that means H will now be equal to 1 over 2, open bracket. Instead of 4 in our example 1, here is now 2. Carbon is 2 plus, what is the number of monovalent atoms surrounding the centralized atom? 1, 2, 3, 4. So it becomes plus 4. Now there is no cation, no anion. There is no cation, no anion. There is no charge present. If it was negative, it would have been anion. If it was positive, it would have been cation. They are not present. So I ignore every other thing. So H will now be equals 1 over 2 times 6, which equals 3. So if hybridization equals 3, what becomes my answer? 1, 2, 3, sp2. So this guy is sp2. That's what now trigonal planar in shape. Now let's see our next one. Our next one, so this is equals sp2. Our next one is for the B part. Now let's see the C. For our C, which is now C2H2. Now what about C2H2? The same thing. H equals 1 over 2, open bracket. The valence electron, which is V, for such a case, remember I've shown you here, is equal to 2. The carbon, the valence of this carbon is 2. So now I have 2 plus, what is the number of monoatomic, monovalent atom that is added to the centralized atom? Is 2. So I come here plus 2. So H is now equals 1 over 2 times 4, which equals 2. If hybridization is 2, what is the answer? sp. So it's now sp. So and what is the shape of sp? Is linear. So it means that this compound here is sp hybridized and has a linear shape. This one here is sp2 hybridized, triangular planar in shape, while this is sp3 hybridized, is tetrahedral in shape. Now let's look at other examples of hybridization question. The first one says, what is the hybridization of this ammonia? This ammonia. Now we are solving with H is equals 1 over 2, open bracket, V plus M minus C plus A. Now let's be fast about this. What is H? Hybridization will now be equal to 1 over 2. Remember, V is the valence of the centralized atom. Now what's the centralized atom here? It's N. N, which is nitrogen. Nitrogen is in group 5. So what's the valence? The number of electron. Nitrogen is 2, 2, 5. That's this because it is N7, which is now 2, 5. So this is the number of valence electron in nitrogen. So that becomes open bracket 5 plus the number of monovalent atoms surrounding nitrogen is 3 hydrogen. So 3 hydrogen, this will now be plus 3. There is no cation, no anion. I end it there. So that will now be equal to 1 over 2 times 8. What is my answer? 4. If my answer is 4, H equals 4, which equals sp3 hybridized. Let's look at the next question. The next question is water. What is the hybridization of water? Now question, what is the centralized atom in water? Is oxygen. So two hydrogen is attached to oxygen. So if I will solve for water, I will say H is equal to 1 over 2 open bracket. The valence electron is water, and what oxygen, sorry, in water is oxygen. Oxygen is 8, which is 2, 6. So the number of valence electron in oxygen is 6. So it becomes 6 plus, how many atoms are surrounding oxygen? Is 2 hydrogen, that's 2. 6 plus 2, there is no cation, no anion. So it becomes H equals 1 over 2 times 8 equals 4. If it's 4, it's sp3. So water is sp3 hybridized. Water has various shape. Now you see that now this particular shape of water is not actually tetrahedra, but we can say okay, water has a V shape, water has an angular shape, water has a bent shape. So we have all of these as shape of water. Now let's look at number 3. Number 3 is PCl5. So now number 3, PCl5. We'll go again. H is equal to 1 over 2 open bracket V plus M minus C plus A. Now, what is the centralized atom here? Is phosphorus. Phosphorus is what now? Phosphorus is 15. So if phosphorus is 15, I have it as P15 is equal to 2, 8, 5. So the valence electron is 5 in phosphorus. So H will now be equal to 1 over 2 open bracket 5 plus the number of monovalent atoms surrounding phosphorus is 5 chlorine. So that is plus 5. There is no cation, no anion. What is now this equal to? It's now equal to 1 over 2 times 10. What's the answer? 5. So if hybridization equals 5, what would that be? Come over here. Let's see that. 1, 2, 3, 4. No. 1, 2, 3, 4, 5. So if hybridization equals 5, what's the hybridization? Is sp3d. That's sp3d. So that's what we have for this. Now let's look at another example. Xenon fluoride. Xenon fluoride. That's for example 4, xenon fluoride. Now, what about xenon fluoride? Let me just solve straight. H equals 1 over 2 open bracket. Xenon is in group 8. Xenon is in group 8. It's a noble gas, an unreacting gas. But although xenon is the only noble gas that can react, so that's why you are seeing something like xenon fluoride. Now, there we have xenon, so it will be 8 because it belongs to group 8. Now, plus, how many fluorine do you have attached to xenon? It's 4. So it's 8 plus 4. There is no cation, no anion. So that becomes H is equals 1 over 2, open bracket, 12. So that becomes 6. So if hybridization equals 6, what do we have? Now look at this. 1, 2, 3, 4, 5, 6. That's sp3 D2. So the hybridization of xenon tetrafluoride is sp3 D2. Now let's look at number 5. Number 5. What about number 5? Now you see number 5, there is a cation, there's an anion attached to it. Now let's see number 5. Number 5 is a very important case. Why? Because the structure there, we have it as XO for 2 minus. Now, H, please make sure you pay attention to this number 5. H is equal to 1 over 2 open bracket. Sulfur is the centralized atom. Sulfur is the centralized atom. Now, what about sulfur? Sulfur is 16. And so sulfur is actually 286. So the number of valence electron is 6. So I'll put here 6 plus. Now you would have said, what is the number of atoms attached to sulfur? You would have said 4 plus 4. No. Remember the law? The law told us that our M is the number of monovalent atom attached to the centralized atom. The number of monovalent, not divalent. The number of monovalent. That's our M. Oxygen is not monovalent. Oxygen is divalent. So because of that, I will put just 0 for it because it's against the rule. So it's not monovalent, it's divalent. So I'll put 0 plus there is an ion here. So do we add or we subtract? Now no cation plus an ion. So I will add plus 2 and close it. Please take note of this. We add anion, but we subtract cation. So we have 2 anion. That's why I'm putting plus 2. I am putting 0 here instead of 4 because oxygen is divalent. M is for monovalent atom, not divalent atom. So now what is now H equal to? 1 over 2 bracket 8. This cancel this 4. So the answer is 4. So for this particular compound or ion, if hybridization equals 4, it is sp3 hybridized. So this is sp3 hybridized. Now let's look at this, which is the last on my list. I have it as number 6, which is H3O plus. Now let's say hydrosomal ion. How can this be solved? The same way. H is equal to, now what is the centralized atom now? Is oxygen. Oxygen is the centralized atom. Hydrogen is surrounding oxygen. So now it becomes 1 over 2, open bracket, oxygen as an element belongs to group 8 and it has 6 electrons in the outer shell. So oxygen is 2, oxygen is this oxygen is 2 and 6. So it has 6 electrons in its outer shell. So my first V here, which is 6, my V here will be 6 for oxygen because V stands for the number of valence electron in the centralized atom. So that's 6 plus. Now, what is the number of monovalent atoms surrounding oxygen? Is 3 hydrogen. So 6 plus 3. So that becomes, now there is a problem now. We have a cation present, 1 cation. What do you do to cation? You subtract cation. So it becomes 6 plus 3 minus 1. The cation is 1, that's why we are subtracting it. There is no anion. So what is H equal to? 1 over 2. This plus this is 9, minus 1 is 8, times 8. What's the answer? 4. If it's 4, it is sp3 hybridized. So you can see that this guy, we've solved for this by adding the anion, while this we solved for this by subtracting the cation, while this by adding the anion. But for this, we said sulfur is centralized, oxygen is not monovalent, is divalent. So we did not include it as the atom surrounding the centralized atom. We just took it as 0. Why? Because the rule only plays for a monovalent atom. Thank you.